In this video, I want to look at calculating the derivative of some of the other key functions that we've talked about during your high school life. So we've talked about the trig functions, or at least a few of them. And what I want to do in this video and the next video is I want to talk about exponential functions and logarithmic functions. Okay, so let's switch over and we'll take a quick look in GeoGebra at the exponential function e to the x power. All right, so what we have here, and we'll do the zooming in power again. So if I'm zooming in on this point 0, 1, all right, this is really a straight line at this point. And what's the slope of the line here? So the slope of the line, we're going up 1 and over 1. So the slope of this line is 1, right at the point where the value of the function itself is 1. So that's an interesting coincidence, maybe. Why don't I zoom in on the point where the y value is equal to 3? All right, so here we have the y value of 3. Let's see if the function of the slope along here is equal to 3. Well, here's a grid point, and so I go up 1, 2, 3, and over 1. So the slope here, where the y value is equal to 3, is equal to 3. Once again, very curious. Let me home in where the y value is 0.5. If the slope here is 0.5, then boy, I feel like we've come up with a rule here. I'm spotting a pattern. All right, there's a pretty good grid point right there. And so we go up 1 and over 2. So son of a gun. So this is enough of a rule for me to kind of make a prediction here. And this can be verified by using really careful math, but we don't have time for that kind of thing, do we? So here we go. When our function is y equals e to the x, when that's the graph of the function we're thinking about, it turns out that the slope dy dx is equal to y itself. So that's a really cool thing about the exponential function. And so we can write it this way, that the derivative with respect to x of e to the x is itself is e to the x. Okay, that's pretty cool. Let's take a look at a different function and see if we can come up with a rule for that. See if it's going to turn out to be the same or maybe not quite the same. All right, so I'm going to home out here. And this was e to the x power. I started off with e to the x, but why don't we switch over to 2 to the x and see if we get the same thing. All right, so I am zooming in here where my y value is equal to 1. And the slope here is not equal to 1. The slope here is, let's see. Well, this looks okay. I can use this as a grid point. So going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. All right, so was that the same as going up 1 and over 3? You're going up 1, 2, over 3. All right, so the slope when y is equal to 2 to the x, we'll make a little table here. So when when our y value is 0, when our y value is 1 here, our slope is 2 over 3, we decided, 1, 2, up 2 over 3. So 0.66. All right, and we'll back out here, press that home button, and let's try it when y is equal to 2. Once again, the slope is not equal to 2 for us. But let's see if we can figure out, well, this is a reasonably good grid point here. So this is up 1, 2, 3, 4, and over 1, 2, 3. So when my y value is 2, my x value is 4 over 3, which is 1.33 or so. And these are just estimates. And let's try when the y value is equal to 3. Where the y value is equal to 3, well, this is pretty close. So here are some pretty close grid points. So we're going up 2 and over 1, roundabout. All right, and so let's go back and look at the table I've come up with here. All right, so here we don't have the same rule that we had, that the derivative was the same as the y value for all of them, but it's a pattern. You know, this is twice as much as this, and this is 3 times as much as this. So that's interesting, at least. So here is the relationship between them. And you'll see that my estimate was off by a little bit. If we were really careful or used larger values, the actual value between these is actually the natural logarithm of 2. So 2 is my exponent, and so the way that the ratio that this is off from e to the x is equal to the natural logarithm of 2. Okay, and so here is what our general rule is going to be for other exponential functions. So when y is equal to a to the x power, the derivative of y with respect to x is equal to the natural logarithm of a times a to the x power. Okay, so it's not as pretty as the exponential function. And this is the reason why when we take exponential functions, it's not 2 to the x or 10 to the x that's the most natural of the exponential or logarithmic functions. Really, taking exponentials to the base e is far more natural. And this is essentially the reason why, that the slope works out really perfectly without having to have a lot of extra factors to kind of pull things in line. So the exponential function is really easy to take the derivative of. Other exponential functions, not so easy. But we'll be dealing with the exponential function almost exclusively in calculus. So we've got that going for us. In the next video, we'll take a look at the logarithmic function and other logarithmic functions to see the relationship that goes on there.